Good morning, learners. My name once again is Mr. Pochilola, your teacher on this platform. Alright, remember it's on this platform where you can come anytime. You visit this channel anytime and you should be able to learn the sciences, including mathematics. Alright, so today we are going to be looking at solved papers, and in particular we are going to go through the 2025 Msce paper, physics paper. This is paper 1. Alright, so this is this is Msce 2025 paper. Alright, it happens to be physics paper 1. Physics paper 1, just some quick details about the paper. The subject number is M164/1. M stands for Msce, and the subject number is 164/1. Stroke 1 means it's paper 1. Alright, so this paper has 100 marks. Alright, so if you add all the marks together, the total mark is 100 marks. It's supposed to run for 2 hours, and on that particular day it was written from 8 o'clock to 10 o'clock, 2 hours. That's fair enough. And take note, you have to know the structure of the paper. The paper contains 2 sections, namely sections A and B. In section A, there are 10 questions which call for short answers, while section B has 3 restricted essay questions. Alright, so that's the paper, the structure of the paper. The paper also allows you to use calculator. That's fine, that's fair enough. And check that the number of marks for each answer is indicated against each question. I always encourage my students to pay attention to marks. The number of marks indicated always give you direction as to how many points you have to include. Alright, in your answer. Alright, so once you finish writing, you have to check the questions you have answered, and tick in this box here if you have answered all the questions. So you tick in this column, tick the questions that you have answered. Alright, if you have not answered some questions, let's suppose for some reason you did not answer question 10, so you leave this part blank. But 11, 12, and 13, if you answered all these questions, indicate by ticking. Alright, you are not supposed to write in the last 2 columns. This is where the examiners, the people marking your paper, will record the marks for each question. Alright, so you're not supposed to write anything in these 2 columns. Okay, so this is the structure of the paper. Alright, so without much ado, let's go to section A of this paper. Alright, section A. Section A There are 10 questions, like we mentioned. There are 10 questions. All right. So, let's go to question number 1. Question number 1 is asking for 2 thermometric substances. All right. What are the 2 thermometric substances? Give any 2 thermometric substances that are used in a liquid in glass thermometer. So the question is assuming that you already know what a thermometric substance is. We define a thermometric substance as any material whose physical properties change in a predictable way with temperature. In other words, is any material which can either expand or contract depending on the change in temperature. All right, so for liquid in glass thermometers, these are thermometers that contain liquids. All right, so the question is simply asking you to give 2 thermometric substances or substances that are used in a liquid in glass thermometers. All right. So without much to do, the liquids, in this case, your answers should be mercury. Mercury is one of the liquids used. All right. Mercury is used because it expands uniformly with temperature, and it is also used in high precision thermometers. All right, but it is not common. It's not commonly used because it is highly toxic. All right, but when it comes to precision, in terms of measuring temperature, it's good because it expands proportionally, uniformly. When you dip the thermometer, the mercury in it will expand uniformly. So they may ask you in an exam why mercury is used as a thermometric substance. It's because it expands uniformly with temperature, but it is also a good conductor of heat. Another one is the alcohol. So mercury and the alcohol are the 2 liquids that are used in a liquid in glass thermometers. All right. Okay, whether you are talking about a clinical thermometer or the common laboratory thermometers or 6 thermometers, all right, these 2 liquids are commonly used. All right, so make sure you know these 2. And by the way, the question is worth the 2 marks. So that means 1 mark is 1 mark per point. Very, very important to note. All right, number 2, calculate the relative density. All right, calculate the relative density. Calculate the relative density. Okay, the question is saying calculate the relative density of a liquid. Calculate the relative density of a liquid of an object in which an object of mass 900 grams weighs 6 newtons when fully immersed in it. All right, so we are calculating the relative density. Take note what we are to calculate. All right, very important question. And the question is assuming that You know the meaning of relative density. Okay. We define relative density, remember, as the density of a substance compared to the density of water. Okay. All right, so we are to calculate relative density of a liquid. All right, in which an object of mass 900 grams, okay, 900 grams, weighs 6 newtons. All right, so that's a very, very important question. When fully immersed in it. All right, so in this case, we are told that the mass is the mass is 900 grams. All right, the mass is 900 grams. Okay, and when placed in water, I mean in the liquid, its weight is 6 newtons. All right, so first of all, you need to convert mass, the given mass, to kilograms, because definitions in physics are usually based on the kilogram, which is the SI unit of mass. So in this case, the mass is given as 900 grams. 900 grams is the same as 0.9 kgs. All right. So when this body is weighed in air, weight in air is going to be equal to roughly 9 newtons. Okay, but you simply take the mass multiplied by acceleration due to gravity. So in this case, we shall take acceleration due to gravity as 10. So in this case, we have 0.9. 0.9 multiplied by 10. So multiplied by 10, which is 9 newtons. All right. But we are told that the weight in the water, the weight of the object in the liquid, let's just call it weight in the liquid, is going to be equal to, it's already given here as 6 newtons. All right. So you can see that in air, the body weighs 9 newtons, but in the liquid, it weighs 6 newtons. So it seems that it has lost some weight. We call it apparent loss in weight. All right, so, and that is equal to upthrust. All right, so upthrust U is simply equal to the weight of the body, weight in the air, minus weight in the liquid, which is equal to 9 newtons, subtract 6 newtons, which in this case is 3 newtons. All right, so let's go back to the definition of in this case, remember, upthrust represents the weight. Upthrust is also equal to, relative density is simply upthrust divided by weight of object in the air. All right. So we are saying relative density is equal to upthrust U divided by weight of the object in the air. All right. And remember, this is the same as upthrust U divided by weight of liquid, weight of equal volume of water. Okay, but in this case we shall stick to the meaning of relative density based on upthrust and the based on what? Based on this definition of upthrust divided by weight in air. So in this case, upthrust is 3. We already found upthrust as 3 newtons. So this divided by weight in air, which is 9. All right, so in this case, 9 newtons. Remember that upthrust has no units. Upthrust does not have units, so the newtons are going to cancel out. They're going to disappear. And this will give you 1/3, which is the same as 0.3. All right, so the relative density in this case is 0.3. So the key ideas, the key important steps that we have included here is to make sure that, first of all, make sure that the mass is in kgs, convert the mass, the given mass, which is grams, to kilograms. All right, so remember that every 1,000 grams is the same as 1 kg. That means 900 grams to kgs, you simply divide 900 by 1,000 to give us 0.9 kgs. And then supposing that you weigh this body in the air, so its weight in air is simply going to be mass times gravity, in this case 0.9 kgs times 10. We assume that we took G to be equal to 10 newtons per kilogram. All right, so in this case the weight in air is going to be 9 newtons, but we are already told that the weight in the liquid is 6 newtons. That means the apparent loss in weight, which is also called upthrust, is going to be 9 newtons, subtract 6 newtons, which is 3. Definition of relative density is, of course, we have several definitions of relative density. Relative density is also equal to density of a substance, density of substance divided by density of water. But that definition here is not going to work. So we are going to use instead another definition of relative density, which is weight of, which is upthrust divided by weight of the body in the air. So we've just found that upthrust is 3 newtons and weight in air of the body is 9. So dividing 3 by 9 gives us relative density of 0.3. So take note, the question is where's the 4 marks? That means the first step is 1 mark. Then we can start from here by converting mass. So we have 1 mark for doing that, another mark for for finding weight in air, all right, and then another mark for finding upthrust, and lastly for finding relative density. All right, I hope we are good on this. So far so good. So we already have 6 marks. All right, part C, figure 1 shows gas particles placed in identical balloons. Okay, by identical balloons, we mean they are same size. They have the same size. Identical here simply means they are same type of material, same size, and so on. All right, that's the meaning of identical. So, which balloon will have greatest pressure when both balloons are heated equally? All right, so here we are given two identical balloons, meaning that they have the same volume. So the volumes are the same. They have same volume. They have same volumes. But the difference between the two, you find that there are few particles here. Here there are more particles. But in this one here, we have few particles. That's the difference between these two. Remember the factors that affect pressure, gas pressure. There are quite a number. Temperature is one of them. Volume and also number of particles. All right, so where we have more particles, when the two balloons are heated equally, it means there are going to be more collisions in S. All right, there are going to be more collisions in S than in R. So which balloon? The question is saying which balloon, for us to say which balloon. So in this case, it is going to be balloon S. Balloon S. All right. So the explanation is simple. We are saying that that's going to be the case because balloon S contains more particles and therefore more particles than R. All right, so that's one mark. All right, so therefore there are more collisions. Therefore you say therefore there are more collisions. Okay, therefore there are more collisions. In S. So there are more collisions in S between particles. You can say there are more collisions between particles. Remember, gas pressure is caused by collisions of particles, and the collision between particles and the walls of the container. All right, more collisions between particles. All right, collisions between particles, hence higher pressure. You say hence higher pressure. So that's the explanation. Okay, of course the question is just 1 mark. Give a reason. We can shorten. You can shorten this to, all right, because the number of marks will always determine how much you have to write. Okay, so you say S contains, it's just 1 mark after all. S contains more particles. particles. More particles. More particles. Alright. Hence more collisions. Hence more collisions. Okay, we can go as far as that. Okay. We don't need to write more than this, because we have already said that it is S which will have greater pressure. The reason is S contains more particles, hence more collisions. All right. That's very, very important. All right. Good. So far, so good. If you are new to the channel, please, for you to see more of these videos where we are solving past multiple papers, don't hesitate to subscribe to the channel so that we revise together. My name once again is Mr. Paul Chilola. I like to be your teacher, and it pleases me to have you learn here. It will be my pleasure for you to have a bit to pass physics very well. Expecting that you are going to get maximum benefit from this channel. All right. In case you have questions, don't hesitate. Don't hesitate to ask. All you simply do is all you have to do is contact me on the number that I shared earlier on in other videos, or just leave a comment. Okay, leave a comment in the comment section, and I'll be very glad to attend to you. All right, so count number 2. Question number 2 is the saying, list any 2 applications of couples in our everyday life. Okay, so first you need to recall what couples are. In physics, the term couple refers to 2 equal and opposite forces whose lines of action do not coincide, and effectively they create a turning effect. Let's suppose we have a body like this one. If you apply a force here, F1, and another force this way, F2. So these 2 forces, F1 and F2, they form a couple. A couple is just 2 forces. All right? 2 equal but opposite forces. So in this case, force F1 is equal to F2. And take note they are opposite. And but their lines of force, their lines of action will not meet. They are parallel. They are parallel forces. All right, so what are they used for? All right, so these effectively will produce a turning effect. Which is called torque. Okay. All right, so we use quite a lot. We use this quite a lot in everyday life. All right. For example, we use this when it comes to turning a tap. So one of the applications is turning a tap. When you're opening a tap, you want to get water from it. All right. you do apply a couple of forces. So one force acts in the direction opposite the other. Another one is turning a steering wheel. We call that steering a car. Steering a car, turning a steering wheel. You want to negotiate a bend, you want to turn. Okay, so you apply two equal opposite forces on the steering wheel, then you'll be able to turn your car. All right. Let's suppose you also want to open a jar lid, a lid from a bottle. Okay, so you also need to apply a moment, to open a couple of forces. Opening, all right. I think opening is single N, single P. Opening a jar lid. Example, a bottle that contains sweets or jam, a jar lid. All right. These are applications of moment. Applications of couple forces. There are quite a number of them. Using a spanner also, you can apply this using a spanner. So the question is just asking for any two. Make sure you know all of these so that you can give any two to get the maximum number of marks. All right. Question number 2. 2B. 2B is asking us to calculate force generated by a car of mass 2 tons, which accelerates at 10 meters per second. All right, so in order to be able to solve a problem like this, you need to understand the meaning of force. What is a force? All right, so force, of course, I know that you know the meaning of force. Force is a push or pull, but that's quite a childish definition of force. So it needs to be remembered that force is equal to, or force is simply the product of mass of a body multiplied by its acceleration. All right. Okay, so force is the product of mass and acceleration. So in this case, we are told mass is 2 tons. 2 tons means 2,000 kgs. This is 2,000 kgs because 1 ton is 1,000 kgs. All right, so we are given 2 tons. That means 2 times 1,000, which is 2,000 tons. And acceleration is given as 10 meters per second square. So all you have to do is to calculate the force. Remember, we are calculating force. So force is going to be equal to the mass of 2,000 kgs, all right, multiplied by 10 meters per second square. All right, so multiplying the two shall give us a force of 20,000. 2,000 times 10 is 20,000. All right, so don't forget. So we have 20,000 kgs, meter per second square. All right. Remember that the final unit of force is the Newton. So you leave your answer in newtons. You leave your answer in newtons. Also check that you have answered, or you have put all the steps there, important ones. A total of 3 marks. All right. 3 marks. Okay. All right. So that's it. If you have any questions, don't hesitate to contact me on the number given, or you can just leave a comment in the comment section. I'll be able to come back to you. My name once again is Mr. Pochilola. I'm in love with teaching you, and welcome. It is going to be my pleasure to have you pass your exams very well. Pass physics, especially pass physics. All right. We're moving on to part C. Let's move on to part C. Part C is asking us to give any two factors that affect inertia of a moving body. Okay. All right, so first of all, you need to understand what inertia is. Remember, inertia is the tendency of a body to resist change in its state of motion. All right? Okay. Suppose we have a body such as a ball, for example. All right, placed on a floor. If you toss this by applying a force, all right, the body will resist to change its position from here to some position there. There's going to be a little bit of resistance. So this resistance or reluctance to change, to move, is called inertia. All right, so it's important to know the meaning of inertia before we attempt to answer the questions. All right, so inertia of a body depends on a number of factors. All right, one of the factors is the mass. So mass affects the inertia of a body. Okay, remember, mass is the quantity of matter. Mass is the quantity of matter. Okay, mass is a quantity of matter. So the heavier the body, the more inertia that body is going to have. Heavier bodies resist change in motion than lighter ones. Okay, so you can mention those. We have one mass of body, but also the type of motion or the size of force. You can include that, size of force. The bigger the force, the easier the body can, the less the resistance the body is going to execute or exert. All right, so we are saying the size of the force, if your force applied on the body is greater, its inertia is going to be less. All right, but also type of motion. The type of motion involved. Type of motion. Okay. Whether the body is at rest initially or the body is already in motion. So a body at rest resists to change, to be moved. Okay. That is explained in laws of motion, Newton's first law. All right. If a body is already moving, it resists changes in speed or direction. All these are factors that would affect the inertia of a body, especially of a body which is already moving. All right, I hope so far so good. All right, let's come to question number 'I think this paper is not properly scanned. Okay, let's come to question number 5A. Yes, it was supposed to be question number 3, but we have been brought to question number 5. Where is question number 2? I think when scanning, this paper was skipped. I mean, this paper, some pages were skipped. All right, anyway, we shall continue in order as it is. All right. So question number 5 is asking us to define half-life as the term used quite a lot in radioactivity. All right, so what is half-life? So we shall define half-life as the time it takes for half of the atoms. Half-life, we shall define half-life in the following manner. The time taken for half of the atoms, in a radioactive substance definition of half-life: to decay or to disintegrate. Remember, radioactivity is the disintegration of the nuclei of atoms in order to release radiation. All right. So that's basically it. A radioactive sample has initial mass of 32 grams. Okay. Has initial sample of initial mass of 32 grams. If the half-life of the sample is 1 week, what mass of the sample will remain? Will have decayed after 4 weeks. So let's do this. All right. Let's go initial mass. Let's call it initial mass as A naught, as is 32 grams. So half-life is 1 week. Okay. Time given is 4 weeks. And we are asked to find the remaining amount. Let's call this A. Okay, so this we are not sure about and we are asked to find. Okay, so we are going to use the equation. Remaining amount is equal to initial amount multiplied by half raised to the power time divided by half-life. This is the formula for finding the remaining amount. So the remaining amount is equal to the initial amount, A naught, multiplied by half, raised to the power time. This time is the given time. And then we have the half-life is more t there. All right, careful. Take note that t, time divided by half-life, is equal to the number of half-lives n. So in this case, it means our equation is going to become the remaining amount is equal to the initial amount multiplied by half raised to the power n. Okay, so in our case, n is simply the given time, which is 4 weeks, divided by half-life, which is 4 divided by 1. Alright, so that means now A, the remaining amount, is going to be equal to 32 grams multiplied by half raised to the power 4. So if you raise 1 to the power 4, you get 32 multiplied by 1 over 2 to the power 4, that's 1 over 16. Alright, so in this case, 16 into 16 is 1, 16 into 32 is 2. That means the remaining amount will be 2 grams. 2 grams. Alright, so that's it. In case you are not sure, please go through the question, the solution quite a number of times, some number of times, until you master the steps. Alright. If you don't have a question, I'm sure so far so good. Let's move on to question number 6. Give 2 factors that affect pressure in solids. First, remember the meaning of pressure. Pressure is simply equal to force divided by area. Okay? That means, therefore, the size of P, the pressure, will depend on the size of the force and the area of contact between the surfaces. So in this case, they are looking for the following. So you say force applied. You say force applied. So pressure depends on size of force applied, and the area of contact. Make sure you know all this so that in the future when you're asked to state them, you don't have problems. Or if they ask for one, just pick any one of them. Or a question can come in a crafty way, like to say, apart from force, state another factor that affects pressure in solids. So you say area of contact. Alright, so far so good. I believe we've been together for quite a long time. I'd like us to stop here for today, and hope to meet you again when we continue with the rest of the paper. But once again, I wish you all the best. Please continue working hard. Exams are not quite far from today. Each time we move to the future, we get closer to the exams. Once again, my name is Mr. Paul Chilola. In case you have questions, don't hesitate to contact me. Bye-bye for now. Bye.